And now I ask, who are you? How much to fix a pipe? Could you please specify if it's residential or commercial? Let's say it's commercial. So it says that it's around $300. Would you like to register? Yes. So full name, phone number, and email address. If we refresh this, we can now see this new request that we now got. Hello and welcome. Today we are gonna build your first lead generation chatbot with Python. This is a beginner tutorial. We're gonna go step by step, and by the end of this video, you'll be able to build a chatbot that can sell for you or for your clients 24/7. It will save leads directly to your CRM or your Airtable or your database. And it's also trained on your knowledge base, on the context based on your business, so it knows how to answer questions regarding your business specifically. The tech stack that we are covering in this video is going to be Python, LangChain. We are going to use the new agentic framework by Pydantic AI, Airtable, OpenAI, function tools, ChromaDB to store the vector, and building the knowledge base. Now, I recommend you to watch these videos before because it will give you more context on what we are actually doing here. So we already built the RAG and knowledge base. We are going to give you a quick reminder in this video. But if you want to go in depth and see what we built over here, you have the code base as well. And today in this video, we're going to take the code base from this video and build on top of it. Now let's show you a quick demo of how it works. So I created this fake Airtable, this fiction business called FlowFix, which is a plumbing service offer plumbing services. And here we are going to see all the leads that are saved for us. So I'm going to run the agent. And now I ask, who are you? I'm a FlowFix AI assistant. How can I assist you? How much to fix a pipe? Could you please specify if it's residential or commercial? Let's say it's commercial. So it says that it's around $300, but it also may vary, depends on different things. Would you like to register? Yes. So full name, phone number, and email address. Let's just copy paste this. If we refresh this, we can now see this new request that we now got. And it also said here, your service request was successfully registered. A team member will contact you soon. Pretty cool, right? So this is what we're gonna build today. So let's start by covering the basics first. So what is an AI agent? Basically a chatbot under the hood is just an AI agent. So what is an AI agent? The best way for me to explain this is to compare workflows versus agents. So in a workflow, you have kind of a linear way of defining it. So you know that you maybe need to do a transcription, turn it into a post, schedule it, and post it. So it's pretty linear. You know what's gonna go one step after the other. With AI agents, you're not sure specifically about the order of the actions, but you know that you need to handle certain use cases and triggers. So usually AI agents come with the ability to use a knowledge base, they have access to an LLM, they have function tools, and this is why it allows you a flexible way to handle customer support or sales or leads or whatever it is. And with simple words, it's just a defined set of actions with no specific order. So in our chatbot, we know that we want to answer questions, we know that we want to save requests, and we also know that kind of the order of it, but maybe we cannot predict the actions of the user. So maybe they ask more questions, maybe they don't want to save the request like we did now in the demo. So with the AI agent, we can handle these non-linear actions pretty accurately and be able to address them. And now let's take a look at the architecture of what an agent actually means based on our definition. So if we take a look, we have the users giving us queries and accessing our chatbot or agent. The agent is combined with a few things. So first of all, the system prompt. The system prompt is just the instructions of the agent. Okay, you should do XYZ, this is your job, this is what you should use, this is your resources, this is who you are, all these things. It also has access to the LLM, the model, OpenAI models, Anthropic, and it helps us process and orchestrate all these things actually. It's connecting all the pieces. It also has access to some memory or chat history of previous chats, and it also has access to actions. In our case, we have 3 actions or 3 tools. So the first one is to save requests. So this one is integrating with Airtable. And every time that we want to save a request or save a lead to our database, we are using this tool. It also has access to this tool, get cost estimate. Whenever the user wants more detailed cost estimate, it's gonna call this tool. And whenever the users are asking questions about the service, it's gonna access our knowledge base. Now, let's give you a quick recap and overview of what is a knowledge base and how it works. We already did it in the previous video, so make sure to watch it. I'm just gonna do it very quickly to give more context. and a quick refresher and reminder. So essentially, our knowledge base is combined from a vector store, and the way we build this vector store is the following. So we have the document. In this case, it's the knowledge about our business, FAQs, case studies, whatever it is that the bot or the chatbot needs to know about our business. We then divide it to parts, chunks, because we don't want to retrieve it all the time, the whole document. We want to make sure that it's efficient and give me only the context that is relevant. We then use an embedding function. Embedding is basically, we take the text and we convert it into a vector of numbers. So for each text in our documents, it's turned into numbers, and we then store it in a special database that is called a vector store. So this is how we build our vector store. Next, we get the user query. The user query is also getting embedded. So it's also turned into numbers, to vector of numbers. Then what's happening is it's taking the vector store, the numbers there, the number of our user query, and it's trying to do a similarity search, trying to find the vectors that are closest in distance mathematically. So if you learned some dot products or linear algebra, you know how to calculate the distance between vectors. You have like Euclidean search, cosine similarity, and this is what's happening behind the scenes. And the LLM is taking the query, it's taking the relevant documents, the relevant context about your business, and answering the question of the user. So that's what's happening. This is a quick overview. I know it was pretty quick. We'll also dive into the code, but again, you can watch the previous video about this topic. And that's how our agent is operating. Now what we're gonna do is we're gonna build this step by step. We're gonna dive into each one of these steps. So if you are a bit confused, wait for it. We're gonna explain each step here. So let's dive into the project, and you actually have the link below to the whole code base on GitHub, and you can follow this README file. Just clone the project to all this, create your virtual environment, install the dependencies, the requirements here. Make sure that you create your .env file and put your API keys. Here you also have instructions on how to get these API keys. And this is where we start. Now we are gonna go to the agent.py file, and we're gonna start by building our agent step by step. The first thing we do is, first of all, we are using here Pydantic AI, which is, as of recording this video, is the new framework for building agents. And for now I really like this framework, so I'm gonna use it more and more. And we start by first defining a simple agent. So we give it a model and we give it a system prompt. Pretty basic if you worked with LLMs so far. And this prompt is coming from our file. So let's take a look. We go to resources. In this case, it comes from the settings. This is the settings of our project. We go to resources prompt and we take a look at our prompt. So again, here we define instructions. So you are Flowfix, an AI assistant. You are in charge of communicating with customers. Your messages should be concise, professional, and solution-oriented. Your primary task is to communicate about plumbing needs, and so on. Knowledge. Company-related information are stored in files accessible. Use the query knowledge base tool. We'll dive into this later. Provide cost estimates. We also tell it, use the get cost estimate function to fetch the estimate. Register services request. We tell it to use register service request. And here is some general rules, like, mention that you are not, acknowledge that you are not a human. If someone is asking, make sure that you're not robotic, all this nice stuff that we want to add on top of this. And when we uncomment those and run it, what we see is Flowfix and AI plumbing services. I'm ready to help you with your needs and so on. How can I assist you today? Okay, so this is the basic agent. Now let's move on to the more complex stuff. So this is this step and also this step. So we have these two. Next, we want to connect the tools. The first tool that we're going to connect is the most complex one, is our answer service questions, our knowledge base. And the process is, as we mentioned before. So we first want to build our vector store. So then we have something to compare to, okay, to compare the user query in this step. Without this vector store, we cannot do the comparison. Then we want to query our vector store, which is this step. This is the query. And then we want to connect it to our agent. So it's a 3-step process that we're going to do step by step. If you go to the README again, you have this command. So what we are doing is we're building the vector store first. And this is going to our file here. The main thing that it's doing here, again, I dive into this in the previous video, is the update database. So when we call this file, It's calling this update database. All it's doing is taking the existing documents and it's also generating chunks. The chunks are generated from this folder. So all the documents that are in the docs folder are gonna turn into chunks and gonna get into our database. So here we get the chunks, we get the existing docs, and we check here. If it's not there in our database yet, we wanna add the documents to our database. If it's already in our database, but it's the content of the document changed, we wanna update it. So that's all it's doing, and it's storing this in our ChromaDB. And ChromaDB under the hood is implementing SQLite. So it's actually a regular database, but with Chroma, we are able to store vectors and numbers in our database. In production, you probably would not use a ChromaDB unless it's low scale. You would use something like PG Vector or Quadrant. Great. So after we built our vector database, let's run a test and query our database. But before that, let's see what it's actually doing. So this is our rag.py, and it's implementing what we mentioned here. So this is exactly what we are doing. We take the DB right now, we take our user query, the question, we perform a similarity search and get only the relevant documents. Then we define this prompt and tell it, answer the question based only on the following context, which is the docs that we got. And this is the question. So we send it to an LLM, the relevant context plus the question, and in return, we get the response. And when we call this main function, all it's doing is taking query from the user and it's calling this query function that is querying the knowledge base. So if I go ahead and copy this one and I'm gonna run it here, it's saying that the cost to fix a pipe for residential property is $80 per hour, which it took it from our knowledge base. So if we open our knowledge base, you see here, routine repairs 80 per hour. So great, it took it from the document. So this was the second stage. Now we have the vector DB, we have the query of the RAG. Now let's connect it to our agent. So we go back to our agent, and this is really the syntax from Pydantic AI, which I'm gonna explain a little bit. So we do the same as we did before. We have our system prompt, but now we also add a tool. What are tools? Again, there is a different video about OpenAI functions, but function tool is essentially the way we handle specific use cases. So in this example, we are defining this tool, and the description is a crucial point here. So the description is saying this tool is useful for when you need to answer questions about service information, service offered, availability, and their costs. So whenever the chatbot or the agent is getting a query from the user, is going through the tool, is going through the system prompt and the tools that it's provided. And it's trying to figure out if this tool is relevant. If it finds a relevant tool, for example, the user is asking a question, it's gonna call this tool. So function tools are essentially kind of triggers that help us handle specific use cases in our chatbot. If, for example, we wanna access the database or do something custom that our LLM cannot perform, like accessing our database, what we will do is we will interject our tool inside the agent, so whenever it gets a request related to our database, it will know to call our function. Okay, so we kind of inject a logic inside the chatbot flow. And this is how it works. So we define the tool and we give it a name. Make sure that on the system prompt, we also define this name, and make sure that you follow it as well. So here we tell it to use the query knowledge base tool. So we give it a name. The function will go through it in a moment. CTX, this is related to Pydantic AI, and the description, okay, when to use this tool. So this is the entry point, okay? So whenever the user is asking questions, it will get to this tool, and this is the implementation of this tool. And in this case, we are using the RAG that we implemented here, and we are taking the query function, and we just call it. So whenever there is a question, move it to this function. Now, the cool thing about function tools as well is that not only it knows the entry point or how to handle this use case, but also it knows how to parse the parameters here. So it takes the user query, it parses it into the question, into the parameter that the function is getting. We will also see this in the other tools, but just know that it knows how to parse the parameters based on our definition here. So if we uncomment this one and we ask how much to fix the pipe for a residential property, this is the same question we asked from the RAG, but before we only added the system prompt. We didn't add the knowledge base. If we run the agent again, this is the response we get. The cost to fix a pipe for residential property starts at $80. And also it's telling us that the price may vary. And it's also saying that it's asking us if we want to register a service request, because we mentioned this in our system prompt. So we now can see the difference between just querying the RAG, but also connecting this to our AI agent with our system prompt. Here, when we queried the RAG, it just gave us an answer to our question, but now when we connect it to our system prompt, plus gave it some context, now we get something that is more human-like or can handle user requests. Okay, so the next thing we do is we define the get cost estimate tool. In this case, I chose to use a different type of syntax, and the reason why is because we are defining query on a different file. So I didn't want to define it again, so what I'm doing is I'm using this syntax. But here, because it's in the same file, I'm using this syntax, and it's basically the same. So the name, in this case, is this name. These are the parameters, and this is the description. So it's really clean syntax, and I really actually like it. So let's see what we are doing here. So this is a tool that has its own system prompt, its own set of instructions, and it's also defined in our prompts folder. Let's go to it, and it's basically just a cost estimate calculator. Your task is to calculate based on the issue and the plumbing type. Use this data to put it, and make sure you output a JSON that has one property estimate that is a number. And here we just combine the system prompt. We send the request with the empty user prompt, and we get the result. Now, what's cool about this tool is that if, for example, we mention the issue, but we don't mention the plumbing type, the agent will know, because of the definition of this tool, it will ask the user back, okay, I know the issue, but tell me, is it commercial or residential? And again, this illustrates the two jobs of the function tool, which is the entry point, when to call this function, and also parsing the user query to match our parameters. So it's consistent throughout the whole flow. So let's uncomment these two and run this again. So initially, without the new tool, it says the cost is 80 per hour. And now with the new tool, it returned a JSON with cost estimate of 150 because we are doing residential. If we'll take a look at our prompt, and yeah, repairing a residential is 150. So it's asking us if we wanna submit a request. And this is our next stage in the sequence. So the final step is to define our register service request. Here what we do is we get a parameter that is called service request. We define here a Pydantic model that is just encapsulating all our parameters in one object: name, phone number, email, description. And this one is really illustrating the power of function tools, because we are not just mentioning here the parameters, it knows how to parse based on our object. So this makes sure that our agents are really reliable. So we give it this parameter, and we also tell it this one is used to register a new service in Airtable. And this one is pretty basic. We are just calling the Airtable API to add a new record to our table. And if you want to test this before running everything, you can just run this one. And finally, if we go to main.py, I created this local test function that's doing the following. So it's running an infinite loop just to illustrate the bot. It's calling our agent, so we are importing our agent from the agent file. So here we have the agent. The agent has these tools. This is the syntax of Pydantic AI. We take it from here. We call the run to call this agent with the query that we get from the CLI. And we also give it the messages history. And this is another cool thing about Pydantic AI. They also give you this function with all the messages history. So if I run this main py file, it gives me this. Who are you? How much to fix a pipe? So this here, he wanted to call the cost estimate, but he saw that there is a missing parameter, which is this one, which is great. So we say that it's residential. Okay, it says that it's 150. It depends on the materials, accessibility, and so on. Would you like to register? Yes, I would like to do some consultation. and they say that they need full name, phone number, and email address. Again, they took it from our tool and definition of the tool. So I say that my name is Jobo, and they say, okay, please provide now the phone number and email address. Thank you, can you give me the email? So this is pretty cool because it makes sure that it has all the data before it's completing the flow or the tool. And after a few seconds, it says that the request was registered and one of the team will contact us soon. If we go to the Airtable and refresh it, we see Jobo, we see that it had like residential pipe repair needed. And by the way, this was inferred from our chat. So it didn't even ask for description because it already inferred it or parsed it from our user query. So that's all for this video. We see how we can build a RAG from scratch, how to connect it to an AI agent, how to save leads from this user query, how to give it more tools to get cost estimate, and really I'll give you the creativity to create your own agents and the capabilities that you can do. And I don't know about you, but this was a really cool project to make. And the next video that we are gonna do, continuing this series, is how to deploy your AI agent, your chatbots, in production in a scalable way. Because we built it in custom code, this can scale pretty well, and it's way faster than using some no-code tools. It's way more accurate and it's way more flexible. So make sure you subscribe and you get notified when this video is coming up next. And what we are gonna cover in this video is we're gonna adjust this agent to handle not just one user. We will see how to build an API around this agent, then deploy this agent and API with AWS Lambda and Docker. And finally, we'll take our agent. Now I showed you some console and CLI, and it's not really, users cannot really use it. We'll show you how you can take this agent, embed it in the website, your website or the client websites, and then it will be able to serve customer requests in production, in real life, with the systems that we built with these videos. Make sure to like this video so the YouTube algorithm knows that is useful and other people will see this. Also, if you have any questions, first of all, make sure to watch the other videos in the channel about function calling, about building your first RAG, and about building a simple AI chatbot with Telegram. But if still you have questions, comment down below. And if you need help building your AI agents in scalable and reliable way, there is a link below to my website. I can consult you for free to see, like, give you some guidance about what are the next steps you should do to build your AI agents. Maybe it's better for you to build with no code. Maybe you need actually custom code for this case. So what we're gonna do, if it's a fit, you're gonna just fill some information in the form below. If it's a fit and if I can help you, we'll jump on a call. I'll give you some different solutions that you can use for your business. And if it's a fit for the type of projects that I'm taking right now, maybe I'll suggest that we also work together. Thank you for watching. I'll see you in the next one. Bye bye.